Now we're boogieing. So again, just like what you were doing before, except this time you just have to do a little bit more. So we're going to identify the h function. So we went up to h, the one that does satisfy the positive 2, which is going to be this one, and we're going to plug in a 2. So that means we're just going to use that function given 4 of 2, 4 times 2, 4 times 2 plus 1. 4 times 2 is 8, plus 1 is 9. Now we have a 3 times whatever that output is, and then we're going to hold on to that for a second. Now we're going to go over here and look at g of 1. So we're looking at our g functions. Which one of these meets the correct domain where 1 counts? So your choice is the first one or the second one. So is 1 less than 3 or is 1 greater than or equal to 3? 1 is going to be less than 3. So we're going to use that equation with our 1 squared plus 2, and you're just plugging it in for x. And I'm hoping that the general understanding of like how to put them in and pick them is not still an issue. I'm thinking it was this part that made it strange for you guys for the most part. If that's not correct, please let me know. So 1 squared is 1 plus 2 gives us 3. That's as 4 times that number. Excuse me. So 9 times 3 is going to give us 27. And 4 times 3 is going to give you 12, which should give you 39 as your final answer. Questions on that guy? And I went kind of fast because I want to get through as much as possible today, but I can absolutely slow down and answer any question if you have one. Okay, good. Well, I got 2 more. So when we're done with this, you're going to be rocking and rolling, Cadence. Okay, so f of negative 4. All of these are f of x, which is perfect. So f of negative 4. So we're going to decide which one meets the need of negative 4. Eli, I made a mistake the last time. I think it was this one that you and I were talking about. One of them, whichever one it was, when I said I made a mistake and the answer was not correct, I was wrong. I went back and looked at it again. So negative 4 is less than negative 3. So we're going to use this one for that one. And so that's going to be negative 2 times a negative 4 minus 4. Negative and negative give us a positive 8 minus 4. We get 4. There's nothing in front of that f, so it's just going to be 4 plus. Then we're going to go over here to 4 of 3. So we got to pick which one works for 3. 3 does not fall between negative 3 and 2. 3 is greater than 2, so we're going to use this one. I wish this equation was darker on my paper. It's not. So negative x, which is going to be a 3 that they gave us here, minus 3 squared, using that equation. So 3 minus 3 is going to give us 0. And I'm writing that negative just to make sure that we remember not to lose it, because if this had been a 2 or any other number, this would matter. 0 squared, though, is 0, and a negative 0 is 0. So it's going to be 4 plus 0. Our answer is 4. Now, they can get a little more complicated, and if I'm going to be probably really honest, on the EOC, they probably will be a little, you know how they like to do it. They like to make it look scary. It's not. I mean, it should not be. It might look it. It's not something out of your bandwidth. So this one is going to be all f of x. So all these functions are f of x. And you can put these in Desmos. The thing about putting them in Desmos is you may or may not want to call one f of x, one g of x, one k of x, so they know which function it is, and set up their domains, and then make sure you change these letters, and it'll test run which one works for you, and it will give you error if you are in the wrong function in Desmos. If you want, I can show you that after we finish solving them. It's not the ideal way to do it, but it is a way to do it if you panic. So f of positive 1. So we're looking for which one meets the positive 1. We have x is less than or equal to negative 2, which is no good. Between negative 2 and positive 2, or greater than or equal to 2. So that one is going to go between negative 2 and positive 2. So I'm going to take that positive 1, plug it in the place of x. So positive 1 minus 2, it's going to give us a negative 1. There's a 4 in the front of it. So that's going to be where we're going to go. And then you can either treat this as a negative 1/2, or I'm going to leave it as a minus and do this guy separately, like as it was a positive 1/2 for the time being. So f of 5, so we got to figure out which function meets the need for f of 5. So is 5 less than or equal to negative 2, between negative 2 and positive 2, or greater than or equal to positive 2? That's going to be this one. And again, this one was not on your test. This one or quiz. This one I would just added for more practice. So we're going to do negative 2, plug in the 5 in the place of x, and then add 4 because that's the equation given. It's going to be a negative 10 plus 4, which is going to give us a negative 6. We have a 1/2 in front of that. F of negative 1. So we're trying to decide, is negative 1 less than or equal to negative 2? And be careful, because I even catch myself when I'm rushing or not paying attention or have a lot going on in my brain. Sometimes it's nice, especially like on EOC day, and this seems so ridiculous, but it's just to give yourself some bearings, to give yourself a small number line. And remember that less than negative 2 is to the left of negative 2. It's easy to say less than negative 2 could be negative 1. Negative 2 is not usually one that people get the most stomped on. It would be like if this was a negative 5, because greater than would be negative 4, negative 3, negative 2, negative 1, and then all your positive numbers. But negative 6 would be less than. Again, not something you don't know when we're conversating about it, but it is a common misconception I've watched students make. So for that negative 1, that is going to fall between negative 2 and positive 2. So we're going to put, there's a times, and we're going to put x minus 2. So that's going to be negative 1 minus, whoops, I'm putting it on the wrong place, minus 1. And that's going to give us a negative 2. Okay, orders of operations do matter. So we are going to multiply first. I would go ahead and solve this. So this is going to give me a negative 4. This would give me a negative 3 with a minus in front of it. So we can put a positive 3 times a negative 2. Orders of operation, and it's just formatting. It could be 4 plus these two multiplied by each other. So we're going to multiply first, parentheses, exponents, multiply and divide left to right, and then add, subtract. So that's going to give me a negative 6 plus a negative 4, and our answer is going to be a negative 10. I don't think these are particularly hard. I think they do require a lot of attention and slowing down. And we're used to just being able to pummel through math really quickly. The slow down part is typically where it's our area of opportunity for most Math 3 students, because you're used to be able to just like kind of throw it out there. So my advice would be slow down. You absolutely know what you're doing. And if I am completely wrong, please let me know by all means. But I have a very good feeling that you know either how to use Desmos to get your answers when it's just like f of negative 5, or you fully understand what you're doing. This guy, I'm not 100% sure why we missed this one. I'm going to look closer at the answers. But when it's f of 5, that's what it's asking for from the graph. That's saying, what is y when x is 5? And this is just back to function notation from Math 1. So we're going to go where x is 5. That's 2, 4, x is 5. In this case, the function is sitting on the 5 right there at 0y. If it was above and below, you just have to decide whether to go up or whether to go down. And it's what is the output when x is 5? In this case, the answer is 0. Because they're at 5, we are at 0. That's where it's touching the x-axis. Any big questions on those guys? A little bit better? Excellent, excellent, excellent. Okay, so like I said, I'm going kind of fast. Because if we can get done early, I'm going to let you guys rock and roll. Inverse function review. I don't know what about this is horrible, besides, again, I think it's just the slowing down and doing the math part. I was checking them this week when you were graphing them because that was part of your attendance assignment, and a lot of them went really awry. So just a quick 3, just basics. Remember, when you're solving for the inverse, the first thing I would do is change this to a y. Switch your x and y. So this is going to be x equals a negative 5 over 8, and I did pick that ugly fraction on purpose, plus 10. Line of great divide. We are now going to solve for y. So solving for y, all of this is all sort of tangled up. So we want to move the 10 first. It's positive, so we're going to subtract 10 from both sides. Depending on your previous math teachers. If you've had me, then you're going to do it this way always. If you've had other teachers, you may do the reciprocal and just flip the whole thing and rock and roll. I'm a big fan of doing each one. This is divided by 8, so we're going to undo it by multiplying by 8. So this is going to multiply by 8, which is going to give us 8x minus 80 equals a negative 5y. And then we're going to divide by negative 5. These guys are gone. So your inverse, and this is much uglier than the ones that I've been having you do so far. We can write this as 8 over 5. It's a positive and a negative, so this is going to be a negative x. Negative 80 divided by a negative 5 is going to give me what? Or 80 divided by 5, because negative is going to give me a positive. Does anybody have an idea what negative 80 divided by 5 is? Divided by negative 5. Beautiful. 16. This should be the inverse of this function. Again, if you go put these in Desmos, they should reflect over the y equals x perfectly, like match identically. Their tables, their x and y values should flip from one to the other if you compare their tables. Squared and square roots, we did one last class, but again, switch to y. Now switch our x's and our y's. We're going to solve for y. Add 4, add 4. It's going to be x plus 4 equals y squared. Now, this guy was a quadratic, and I definitely said this last time, but I can't say it enough because this is where I've had the most students give me feedback that they get confused. So you're going to have that full parabola. When it reflects over that diagonal line of y equals x, it's going to give you half a parabola back, just the root function, which is not crossed down into the negative. It doesn't have the other side. So we have x squared. The inverse of squaring something is square root. So we're going to square root both sides. That gets rid of that 2. So it's going to be the square root of x plus 4 equals y. Again, I said it last week or last class. It's been, like you said, a long week. All of that is underneath the root bar. If you do not put it in correctly into Desmos, it will not mirror. If it doesn't mirror, that means you did it wrong or you're inputting it wrong into Desmos. So slow down and check. Last but not least, for our inverse review, we're going to change f of x to y. We're going to switch our x's and our y's. Now we're going to solve for y. Y and 5 are underneath that root bar. So we're going to square to get rid of the square root. And that's going to get rid of our root bar. Those go away. So I end up with x squared equals y plus 5. Again, line a great divide. We're trying to get y by itself. The inverse of adding 5 is going to be subtracting 5. So x squared minus 5 equals y. And this is that quadratic, which would be the reflection of the root function over the y equals x. Now, I just did those smoking fast. And that's partially because you guys were the exact guys that were here earlier in the week. Do you have questions or call outs as far as inverse functions are concerned? There's usually one EOC question, of inverse. I feel like it's something you could type in usually into Desmos and kind of like troubleshoot through it. But we want to, if there's a question I can answer or something I can make more clear, let me know. Awesome. I love it. If you're pretty strong at solving equations, it should not be a huge deal. But again, I think it comes back to that like slowing down and realizing you do know all the math and you should be confident, but it's the process of slowing down and or writing more neatly so you can track your work. I was working with another student from Math 4 in person yesterday. Lots of fun math. And the biggest problem was she just couldn't track her work because of the way she wrote. And I know by math 3, that seems like a weird time to start telling you to write neatly. Huge, huge difference. Trust me, watching students. All right, enough of my soapbox. So today's lesson, and you can get around maybe watching the notes part if you want today, as long as you understood pretty fluently what you did yesterday. So yesterday was converting between logarithmic and exponential. It's explaining that those are the inverses of each other, which is why we started with inverses and then slid into log and exponents. That's the context of the two. The end of the day, you're solving them. Solving and graphing. And we're going to graph next week and identifying the parts that are important. But as long as you can convert, then you could skip today's notes if we could get through these. Ask me questions too, please. And again, it'll save you the time of watching those note videos. If you want the note videos, by all means. But it's Friday. You may not. Okay, so log. You're going to convert it whenever there's an x in the parentheses. So on the side with log, if there's an x, you need to convert it to exponential to be able to solve it. And this is saying it's harder. We're not as fluid with logs, so I like to convert it and then tell you the sentence, like the conversational question that it's asking you. So we're going to grab our base in the basement. I call this the basement. Go grab our exponent and come out with our output. So that's going to be 2 in the basement, raised to the 5th power equals unknown. So 2 raised to the 5th power equals what is all this question is asking, even though it says log base 2 of x equals 5. So it's 2 to the 5th power equals what? And that is going to give us 32. Now, I have argued with some students along the way, more in-person class, that some of these numbers you're going to be able to like just see it and know it. That's awesome. Still practice the process because we're in math 3, and let's be honest, they're not giving you much. You're going to need to use a calculator. You're going to need to understand the processing of it. Everybody good on converting from log to exponential? It does make a cursive E. Most of these videos are the ones I taught, so you should get my like cursive E when you're going to exponential. Some weird fat L when you're going to logarithmic. Converting, are we okay? And when I say converting, I mean switching between exponential and log. All right, beautiful. Okay, so the next one, again, still solving. Cool part is if you happen to Google this or watch a video or go look for more help because you don't want to ask me, we are not using logarithmic like the rules. So if you see something about rules, back out. That's math 4. Okay, that's not one of our standards. And I only say that because I know some people go digging a little deeper. I probably would highly recommend reaching out to me instead of doing a lot more of your own research. But, so we're going to grab our base, go grab our output, our exponent, and then we're going to come out with an output. These two are very similar. The only thing that changed is there's more action going on with inside the parentheses. But that x is still in the basement or down here with log. And it is inside the parentheses. So all of the mess is inside the parentheses would be the call out on this guy. Now I'm jumping pretty fast from super easy to getting a little more difficult to getting kind of wild. So again, if you need to go back and watch today's notes, it is a bunch of examples starting basic and working their way up. It's like literally 4 videos broken down, progressively getting harder. So maybe even just skip to the back half of the notes if you want. 2 to the 5th, we said was 32. And now we're back, flashback to math 1. We're just solving for x or 8th grade math, whenever you are the happiest. We want it to be a good thing. So plus 7, we're going to subtract 7 from both sides. And we're going to end up with 25 equals 5x. 5x, remember, is 5 times x. So the inverse is going to divide. And the answer to this one is x equals 5. So not much different. Again, if the x is in the parentheses and it says log, you're going to convert it. If the x is down in the basement or if it's on the outside, you're going to use like log to solve it. Like if it's equals to x or equals to 2x, you're going to solve it that way. And you can type log base 2 of 32 into Desmos and it gives you 5. Because that x, log base 2 of 32, if you type that into Desmos, it should give you a positive 5 out as your answer. Change of base you're going to see over the next couple of days just to cover it, to say you've seen it. Because there were a lot of TI-83s and 84s, at least at Pinecrest, that did not have the updated software. where you couldn't type in a change, like change the base to a 2, 3, 4, 5, because log button on a TI-84 is a log base 10. So the assumed, kind of like there's an assumed 1 in front of an X, is 10. Kind of like there's a 2 in the assumed square root. Log base 10 is your assumed. This is the change of base, and that's just allowing you to use that log button on the home screen and not do much digging on a TI-83, 84, or some other calculator that has some basic programming. But we have Desmos, so you can plug it in just like that. Whoever's at the bottom of the fraction, the denominator, is the basement. That's the way I remember it. If it's in the basement, it stays in the basement for change of base. Now, do we need to do another one of these, or are we okay? Because this one I think is pretty close to the same. Base 3, grab 5, come out and solve for x. So base 3 raised to the 5th power equals 4x plus 3. Do you want me to solve that one? Okay, cool. I feel like that at that point you should be, hopefully, check, moving on. So this beautiful guy here, super simple like the one before. This one changes. There, you have to have log base of equals blank, and that's it. Log base of 3, log base of 3, log base of 3, log base, man, hello. Log base 3 of 4x plus 3 is 25. This is perfect for converting. Problem is we have this 5 in the front. That is multiplied. 5 times log base 3 of 4x plus 3 equals 25. Got it that time, thank goodness. We have to get that off before we can do our cursive E. So we're going to divide both sides by 5, and I'm dividing because that's multiplication. Okay? And at that point, I end up at the exact same place as I was. So log base 3, 4x plus 3 is 5. Exactly the same. So then it is going to convert this way, and you would get the same answer. So if there's anything attached on the side with log, other than the set of parentheses with the x, you got to get rid of it first. So looking at the next one, log base 2 of 4x plus 8 minus 3 equals 5. Remember again, you need log base 2 of is a number. This guy is in our way. He's a problem. We can't just cursive E and get out of here. We have to fix him first. So he's attached by subtraction. So you're going to add 3 to both sides. So now we're looking at log base 2 of 4x plus 8 is 8. Then from here, it is log base 2 of 4x plus 8 is 8. So now we can convert it. Grab our base, go grab our exponent, and come out with our output. So 2 to the 8th power is 4x plus 8. Again, that's just a matter of plugging this in your calculator, figuring out what 2 to the 8th is, and then solving for x. These are gifts. This next guy, log base 2 equals log base 2. If the two log base match, so if this guy and this guy are the same, they cross out, you're sitting in beautiful, like, I don't know, 9th grade again. Variables on both sides, just solve for x. That's it. So if log base match, so if they're exactly the same, cross them out and solve. So they disappear. They just go away if they're the same. You take your two parentheses, set them equal, and solve for x. Pressing questions yet? Am I going too fast? All right, beautiful. Exponents. So I'll just throw them on here. It's the exact same thing. It's just the opposite. So if the x is in the exponent, so it's up in the air, you have to convert it to logs. So if you can think back to Math 1 when you did growth and decay, and you needed to solve for time, and you would plug in that equation in your y equals, you would go to your table and you would scan around forever and try to find it. Or if you're in a classroom, your teacher's like, oh, we're just going to pause. That's not part of our standard. We'll worry about that later. This is later. So at any point when you're solving for x, in the exponent, you're going to switch it to log. And this is where I was saying that I call it like an ugly L. So we're going to push the base down into the basement of 17 is exponent. So equal exponent is the way I kind of, when I didn't know this fluidly, like to be able to give people like some little hacks and stuff. Base is always in the basement. And by basement, I mean that subscript down. Our outside is what's going to come inside, and it's going to equal exponent. Equal exponent. And again, this is just the conversion like hack if you're having still some trouble with getting it to flip around and work. Now that we're in log base 3 of 17 is x, you can type that in just like that into Desmos, or again, for change of base, just to make sure you can say you've heard it. If you go to college and somebody mention it, you can't say you have had the worst high school math teacher and she never showed you. Again, or also if you end up with a calculator for some odd reason and no Desmos, you can type it in that way, and our answer is going to be 2.58. I would say not a promise every single, not 100%, like probably in my opinion, like 97.9% of the time. These are not going to be nice, beautiful whole numbers. Because if they were, like if I said 3 to the x equals 9, solve for x, you know 3 squared is 9, so there's no reason to practice logs. They're going to give you a problem again that shows that you know the skill. So it's not going to be numbers that you should just be able to rattle off. In notes, in the beginning, some very basic practice, maybe. But EOC, end of unit, probably not going to be things like that. It's going to be numbers that are going to be a lot less obvious. All right, so one more basic just to make sure. We're going to push our base down into the basement. Output equals exponent. So log base 6 of 51 is x. So again, change of base, straight line stays on top, basement stays in the basement. Whoop, I just made up a number. That should be a 6. So log 51 divide by log 6, or again, type it in straight as we converted it, minus the x part into Desmos, and you should get your answer as well. And that's going to give us a 2.19. Just like the previous, we need a base, we need an exponent, and we need an output. This guy, don't panic. There's a lot going on, or extra going on in the exponent, that x plus 10, but ultimately it's still a base, an output, and an exponent. So log base 9 of 78 is x plus 10. So log 78 divided by log 9, if you choose to use change of base. Maybe it's just because I'm old. I kind of like it. And I don't always like switching my screens around to go find Desmos. You can actually do that in your calculator on your phone too, for most phones. And that's going to give me 1.98. For me, and I probably have not said this enough in Math 3, do not ever, 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 do not ever round to a whole number. This is Math 3. This is serious math. When you go to Math 4 or pre-cal, wherever you go after this class, and then go to college, you won't do math like you always say, when am I going to use this in real life? Unless it matters. And if it matters, pennies matter, dimes matter, nickels matter. So decimals matter. No whole numbers. We're not rounding to whole numbers unless for some strange reason it tells you at the top, round to a whole number. I personally like 2 decimal places as a general rule because it keeps you close enough to accurate that if they choose to use 3 or they use 1, or they did use a whole number, your answer is not going to be so far off from theirs that you won't be able to find it if it's multiple choice. So 2 decimal places is my like general rule, because then you can discuss things no matter what they do to you. If you round it to a whole number or 1 decimal place with multiplication and some of the style of math we're going to do, it can significantly change your answer. So for SIG's math, let's go with 2 decimal places if there is no specific rules already stated. Like Delta Math will tell you that it wants to the 10th or the 100th and all of that good fun stuff, or 1000th place, which is 3. So in that case, also make sure you're reading directions. So now we're just going to subtract 10 from both sides. Off my soapbox again. Sorry, guys. And we're going to end up with a negative 8.02 as our answer. So it looks a little fancier, but really not. These two guys are the ones that are fancier. Again, you need a base, an output, and an exponent. This is our base, this is our output, this is our exponent. This guy's in our way. Super easy to move him. We're going to add 5 to both sides. So it's now going to give me 11. So that's our base. Raised to an exponent equals 59, an output. Now we can convert it. So push him down into the basement. Output equals exponent. So log base 11, 59 equals x minus 8. So again, you're going to type that into your calculator. So whether you do change of base or you do Desmos, or you can use the correct notation in your calculator, there is a way to get it in a TI-83 or 84 too, if the programming is correct. X is not by itself yet. That is a negative 8. So we're going to add 8 to both sides. And our answer is going to be 9.7. If you want to put a 0 behind it, that's beautiful too. Last but not least, guys, it's Friday. This is going to be the last one, I promise. This is multiplication. We can't have multiplication, base, exponent, output. You need base, exponent, output, and that's it. So to undo multiplication, we're going to fix it and divide both sides by 5. That gets rid of that guy. And that's going to give us 6 to the 3x equals 4. Because 20 divided by 5 is 4. Push him down into the basement. Log base 6 of 4 equals exponent. Log base 6 of 4 equals 3x. Again, you're going to get a number when you do log 4 divided by log 6 or log base 4 of 6. Oh no. Sorry, mine messed up. Having fat fingers issues over here. And that's going to give us 0.77 equals 3x. That's 3 times x. So we're going to divide by 3. Again, those days of not dealing with ugly decimals are over. Welcome to high-level math, and decimals matter. So make sure we're rounding correctly too. This is 579. I would like it probably as 0.26, 0.258. But remember, if it's 5 or greater, always rounds up. And rounding, I will not give partial credit for rounding, especially after like next week, because we are in Math 3, and this is the real world.